So today we're going to do trigonometry. And there are a lot of facets of trigonometry that you'll get into in other classes. We're going to do some very basic trigonometry, which is commonly called right triangle trig. It's called right triangle trig because it only applies to right triangles. But we've been working a lot with right triangles, so this shouldn't be a big deal. Later on, we'll get into some other trigonometry that we're going to use to solve a simple problem. And the simple problem is, well, what happens if it's not a right triangle? What do we do then? Oh, we've got a technique for that, but we're going to basically crawl before we walk. Okay. We have to get comfortable with labeling a triangle. And this is just one possibility, but there's some stuff here that I want to emphasize. So I have this right triangle, and it's labeled A, B, and C. So notice the vertices are labeled with capital letters because we use capital letters to represent points. The key is realizing how the rest of the triangle is labeled. So lowercase a, lowercase b, and lowercase c represent the lengths of the sides. Capital letters are vertices, lowercase letters are side lengths. And those values are across from the angles. Lowercase a is across from the vertex A. Lowercase b is opposite from the vertex B. Lowercase c is opposite, or sorry, lowercase c is opposite from the angle C. Now, does this mean that every triangle you work with in this chapter is going to be labeled ABC where C is the right angle? Absolutely not. And so I want you to be comfortable with the labeling technique regardless of what the triangle looks like. Okay, so while you're writing, let me give you an example of what I'm talking about. Let's suppose I have a triangle. I have a triangle XYZ with Z being I know how to spell, being 90 degrees. Okay. Could you draw a triangle like that and label it correctly? Well, what do we do? I'm going to just go over this one. So I'll get rid of these, and we're going to build on top of this. So first things first, I know Z has to be down here because it's the right angle. Which one's X and which one's Y? It doesn't matter. I'll put an X here and a Y there. You could do it the other way. Okay, that's the easy part. The part that's going to require a little bit of practice then is where is side X, where is side Y, and where is side Z? Okay, Z would be over here, lowercase x would be over here, Y would be over here because they're across from each of the angles. Does that seem like a pretty simple concept? Okay, I don't want to beat a dead horse here, but I just want to make sure that we get it done. Not every problem is going to give you a picture for you to work with. A lot of times you're going to have to write or create your own picture. Okay. Are we good? Excellent. Okay, now we're going to do some trig. These are functions. Okay, we'll get back to that in a second. A lot of the stuff that we're doing in this class, or in any math class, are simply functions. Well, what's a function? A function is a thing, for lack of a better term, that takes a number or takes a scenario and changes it into something else. Okay, so let's take something simple, addition. Addition is a function. What does it do? Well, it's so simple it's hard to explain, but addition is a function that takes two numbers and adds them together. What is multiplication? Well, it takes two numbers and it multiplies together and spits out another number. Your life can be made a lot easier if you understand that these trig functions, sine, cosine, and tangent is how they're pronounced, are simply functions. You take a number, you put it into this function, and it spits out another number. Okay? If you take a function like squaring, that's a function. It takes a number and it squares it. You put in a 4, it spits out a 16. That's the basis of a function, and these do the exact same thing. Any problems? Okay, good. Now all you need to know is what do these things do. If you look at your calculator, for instance, there are 3 buttons on your calculator. SIN, COS, and TAN. Please don't call them sin, cos, and tan. Sine, cosine, and tangent. And those are like magic buttons. Okay, so just type in a number. Type in the day of the month you were born. No, hold on, sorry. Hit the sign button, SIN, and then type in the day of the number of the day of the month that you were born. And then hit enter. Okay? It just spits out a number, right? You have no idea what that number means. It's probably a decimal value, yeah? Probably pretty ugly. Okay? We're going to learn where that number comes from, but for now, you don't need to understand. Have you ever heard the expression that you're better off not knowing what's in the sausage? Or how the sausage is made? Have you ever heard that before? It basically means just leave the sausage alone, just eat it. You don't want to know what's in it, okay? Because there's some pretty disgusting stuff in here. The same thing is true early on with trig. We don't care where that number comes from because you have this cool calculator that will do all the work. But we still need to kind of understand how they come about, and we're going to stay with the KISS method here. And we're going to define each of these functions, and there's a lot on this screen, so I'm going to talk it through while you're writing. Regardless of whatever we talk about, the thing to remember about the trig functions is they're simply ratios. That's it. Boom. Done. Now, where did those ratios come from? Well, that's what all these charts are. So the sine of some angle, I just happen to choose A, is the length of the opposite side over the hypotenuse. Look up here for a second. We'll deal with this column in a second. Just focus on these two things. Okay. Cosine is defined as the length of the adjacent side. What does adjacent mean? Next to. Over the length of the hypotenuse. And then tangent is defined as the length of the opposite side over the adjacent side. If you know people that have already had this in math class, you might have heard the following expression. SOHCAHTOA. What does that mean? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so since we're back to traditional old school notes, as we're going through this, if I'm going too fast or you miss something, please do not hesitate to raise your hand or shout, and I can slow down or I can go back to a slide. I don't want you to miss any of this stuff, especially today, because this stuff is crucially important. Are we good?
No.
Not yet? Okay, that's fine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. So in other words, if I take all this mucky muck up here and I get rid of this, I've got opposite over hypotenuse, get rid of this, and this, adjacent over hypotenuse, get rid of this, and all of that, and we get down to that part. Make sense?
Yeah.
Okay. Just an easier way to remember. Okay, so let's talk about that last column then on the right. Where did the A and the C come from? You'll notice I'm taking the sine of angle A. So I'm working with this angle. And from that angle, there are three sides we're concerned about. The opposite side, the adjacent side, and the hypotenuse. Let's do the easy one. The opposite side is the side across the triangle. So it would be A. Okay, that would be the opposite side. There are two sides that are next to angle A, C or B. One is the hypotenuse and one is the adjacent side. Well, the hypotenuse has to always be the hypotenuse. So this would be the hypotenuse. And that, by process of elimination, we get B being the adjacent side. Then you just plug and chug into the ratio. So if we're looking at the sine of angle A, it's the opposite side, which is lowercase a, over the hypotenuse, lowercase c. A over c. Done. Any problems? Okay, so let's change it a little bit just to make sure that you're with me. Let's go to green, and let's talk about the sine of angle B. All right, now we're dealing with this angle. Which side is opposite angle B? Lowercase b, very good. Which one's the hypotenuse? C, done. Okay, again, keeping it simple. What is the cosine of angle B? Say again? Not uppercase. Lowercase a over c. Okay, so if we're talking B, this becomes the adjacent side. It's next to. This is the hypotenuse. And then last but not least, what's the tangent of B? Opposite side is B. Adjacent side is A. Okay. It will change from side to side. What we will avoid frequently is dealing with the right angle because that causes some problems. Because now all of a sudden, if you start talking about angle C, we have sides that are both the opposite side and the hypotenuse. We have sides that are, both sides will fit into the adjacent category. So the best way to deal with that is we just don't. We avoid the right angle whenever possible. Okay, so I need some feedback. Does this make sense? Any problems? Any clarification? Because this, if you've got this, the rest of this should be pretty easy, theoretically. But I want to make sure we're good to go. Okay? Beautiful. Go here, put that back. All right, so let's practice. Now, we did this already, but let's do it with numbers now. And I'll let you do this on your own. So across the top, find the sine of A, the cosine of A, the tangent of A, the sine of P, the cosine of P, and the tangent of P. And then we'll talk about why we're avoiding the angle E whenever possible. Whoops, sorry. We'll do A in green. And we'll do purple for P, as in Puma. You tell me. Great question. So the question was just asked, if you're talking about adjacent to angle A, couldn't it be 3 or 5? Because they're both next to angle A, right? Which one is it, though? Because? Good, 5 is the hypotenuse. All right, Ben, you're up. Do you want angle A or angle P?
Angle A.
A, okay, let me switch to green. What's the sine of angle A, Ben?
4 over 5.
The cosine of A?
3 over 5.
The tangent of A?
4 over 3.
Do you all agree with him?
Yes.
Any problems? Perfect. Thank you, Ben. Aiden, you have P. Sine of P? Over. Well done. Cosine of P?
4 over 5.
Bring it home. Well done. Any problems there? Excellent. Okay, so just for giggles, let's switch to, I don't know, orange, yellow. Is that yellow or orange? I don't know. What happens when you try to take the tangent of angle E? And it's the opposite side, it causes all kinds of problems, right? Yeah. Okay, so on your calculators, type in the tangent of 90 degrees. What do you get? What is it?
Negative 1.9.
Error. Oh, I guess we should back up. Hold on, I should have done this before. Find the mode button on your calculator, up on the top, and make sure your calculator is in degrees mode, not radians. Okay? So here's the issue. If you're in radians mode, there's no indication that you're in radians mode. It will still give you answers, it's just those answers are wrong. If you've switched to degrees mode and you're the only one that uses your calculator, you should be fine. If, however, you share your calculator with someone, you loan it to somebody, your brother or sister uses it, whatever, you're going to need to check every time to make sure it's in degrees mode. Or, right before a quiz, if you want to have some fun and your neighbor gets up and goes to the bathroom, just reach over and change their calculator to radians. That's always a good joke. That's funny. Yeah. All right, so now, Eva, you good now when you take the tangent of E, you get an error?
Yeah.
So why do we get an error for the tangent of 90 degrees? Because the calculator doesn't know, are we considering that the hypotenuse or the opposite side, and it causes all kinds of problems. So we're going to avoid that like the plague. All right, issues now. And again, going back to what I talked about earlier in the slideshow, the trig functions are simply ratios. That's all that Ben and Aiden did, is they just gave us 6 ratios. Okay? This is the easy stuff. Any problems? Now, is that practical? Does that do anything for us? Absolutely not. So we're going to transition then into how we can use this to actually solve problems. But again, let's check to make sure your calculator is working correctly. Type in those 3 things and see what you get for answers. So what's the cosine of 41 degrees? Riku? 0.755. Can you all confirm that?
Yeah.
Good. If you didn't get 0.755, odds are you're probably in radians mode, so check that. Lena, what's the tangent of 74 degrees? 3.73. Yes? 3.487?
Yeah.
Tangent of 74? Yeah, okay. And then sine of 2. I think we're beating a dead horse here, but we're all good to go, yes? Okay. So now let me give you the old man discussion. You guys have a serious advantage in using your calculators. So I know that many of you go, when you leave the classroom and you take the pass with you, you probably never looked at it. But this pass is actually an old desktop. So the desks in this classroom had these desktops, and you would flip it over depending on what you needed. So if, for instance, you were doing some graphing, this side is a graph that you could do polar graphing on. The other side of this, however, is what we called trig tables and logarithmic tables. So we used to have to look this kind of stuff up. So if I'm looking for the cosine of 41 degrees, I would have to go cosine 41 is over here somewhere. And I can't even figure out how to work this stupid thing, plus my name is carving out a bunch of the stuff. But we'd have to look it up. Okay, so if we do, what do we do, sine of 2? All right, so somebody tell me what the sine of 2 degrees is. Is it 0.0349? Yeah, so we'd have to look that crap up. And if you look at it, that's just all the degree measures that you would possibly be looking for. Okay, so you'd have to have a desktop in order to solve it. And then every time you took a quiz or a test, you'd have a sheet that had all the angle measures that you would have to look up. So the nice thing about the calculator is it does all that work. So that was kind of a back in my day type thing. Where did I put my clicker? All right, so we're all in the same degree mode. We're all good to go. So let's start solving some problems. We can use trig to solve problems and actually find distances in triangles where it appears we don't have enough information. So we've started solving triangles using Pythagorean theorem where we know two of the sides and it happens to be a right triangle. We're going to use trig to solve problems like this. I can't use Pythagorean theorem because I don't have two of the three sides, so now I'm going to switch to trig. I'm going to go very slow through this first example so that you can stay with me, and then I'll cut you loose to do one on your own. Okay. If I lose you along the way, don't hesitate to ask. Okay, so let me ask a simple question to start. How big is that angle? 50, correct. Why?
Because the other angle is 90 degrees. 90 plus 40 is 130. And a triangle adds up to 180.
Perfect. One possible answer. The other possible answer is, anytime you're in a right triangle, one of them is 90. So 180 minus 90 means these two angles have to add up to be 90. It's the same thing, just a different way to approach it. Okay. And that angle is exactly 50 degrees. So you could choose to use the 50-degree angle if you want. We're not going to. We're going to stay with the 40. Okay. The secret to solving trig is setting up your equation. That's it. The rest is just simple algebra. Okay. Let's start solving for x first. We're going to solve for x, and we're going to use the 40-degree angle. Okay. So I asked myself a couple questions. With respect to the 40-degree angle, is the side labeled x the hypotenuse, the opposite, or the adjacent side? Opposite. We're all good to go with that, yes? And in fact, I'm going to put a note here because it's our first time we're going to do that. And then I have some given information, which is the 3 meters. Is that the adjacent side or the hypotenuse? Hypotenuse. Beautiful. Okay, now the hard one. What trig function uses the opposite and the hypotenuse? Sine. Very good. Okay. Any questions on that process? Good. That's the hard part. Now we just set up an equation. The sine of 40 degrees, okay, the sine of the angle is equal to the length of the opposite side over the hypotenuse. Before we even solve this, what can you tell me about the length of x? Go ahead, Sebastian. What must it be bigger than? 0. What must it be smaller than? 3. Okay. Now, is that relevant to solving the problem? No, but it will act as a checks and balances. If I solve the problem and I find out that x is 4.6, I did something wrong. Okay, solve that. Tell me what x is. And then we'll talk about some of the mistakes you might have made if you got an answer that doesn't make any sense. Ben?
I got 1.93.
All right, so the suggestion is 1.93. Can somebody confirm? We're good? Okay. If you got an answer that doesn't match 1.93, there could be a couple reasons for that. I'm assuming you all realize that we're going to multiply both sides by 3 to get x. If you typed it into your calculator by doing this exact keystroke, sine of 40 times 3, you will get the wrong answer. Why? Well, when you type sine into your calculator, it automatically creates a parenthesis, yeah?
Yeah.
And then you type 40, if you don't close the parentheses and just do times 3, what is the calculator going to do? Good, it's going to take the sine of 120 degrees. So how do you solve that problem? 2 ways. Either close the parentheses, or what I like to do is bring the 3 in front. 3 times the sine of 40 doesn't cause any problems. So if you didn't get 1.93, try to type it back into your calculator and make sure you get the right answer. Now, Ben, I'm assuming that number is a big, long decimal, right? It wasn't as pretty as 1.93. You rounded to 2 decimal places. Okay. We want to avoid using calculated information. Well, what do I mean by that? Well, now that we know x, I could very well go and apply Pythagorean theorem now, but if I apply Pythagorean theorem, I'm using a rounded value of 1.93 and my answer is going to be off. So I don't want to do that. I want to solve for y using trig. Okay, so we're going to go through the same process I went through to get x, but now we're going to solve for y. Okay, since we have all this labeled, I know that y is the adjacent side. We're going to stay with the given information. So what function uses adjacent and hypotenuse? Cosine. Beautiful. Set up your equation. Cosine of 40 degrees is equal to y over 3. Solve that, please, and tell me what it equals. Jack. 2.3. Can somebody confirm?
Yes.
Excellent. Okay. Any problems? All right, good. Another checks and balances here is this guy. SML. SML stands for small, medium, large, and it's a theorem. This is a very useful theorem. The only thing this theorem will do for you is allow you to look at your problem and say, I probably did it right, or I screwed something up. And the small, medium, large theorem says something very simple. The smallest side is always opposite the smallest angle. The medium side is opposite the medium angle. The largest side is opposite the largest angle. Okay, so when I get done with this problem, I'm then going to go back to the small, medium, large theorem and see if it makes sense. Well, my smallest angle is the 40-degree angle. Therefore, it should be opposite the smallest side, and it is, because we found that to be 1.93. The medium angle is 50. It's opposite the medium angle of the medium side of the 2.3, and of course, that has to be my hypotenuse. Okay, so the small, medium, large theorem is a theorem that encompasses everything that we already talked about, with like the hypotenuse being the longest side all the time, and that x had to be less than 3 but greater than 0. Okay, so it's kind of a checks and balances that you can use when you're solving these problems. Any trouble? Don't be bashful. Ask now, because it's about to ramp up a little bit. We're good? Excellent. Okay. Let me get this mess out of the way, and then I'll let you solve one on your own. Erasing. Okay, solve that for R and S, please. Now, the nice thing about being on paper is if the orientation of that triangle is freaking you out because the right angle is up on top, then just draw your triangle different. Flip it over. Or do it like that. Okay. Solve for R and S. When you get done, check with your neighbor. Make sure they have the same answers. If not, figure out who screwed up and fix it. Real quick before you dive into it. Which side will be the longest? S. Which side will be the smallest? R. Okay. So that should help as a guideline as to how to solve this.
Right.
I'm going to get more water.
So then it would be.
He did for S. S. Oh.
So it would be 10. So R is,
Oh.
is that S down?
So if for S, it would have been cosine.
R as,
So divine S is like cosine. Adjacent and hypotenuse.
so
Wait, cosine adjacent is 50.5, but one is the same.
S yet.
Yeah. So 15.5
No, but it should be
equals S. It was cosine. 15.5 times 35. 33. Oh my god. Yeah, because it has to.
No, it has to be bigger than 35. Like too big.
It makes sense.
Is that this?
Smaller.
No. Okay, if you look, we got for Y, we got like 2.3. That's smaller than the one that's not by
All right, how we doing?
I was looking for 33.7.
I heard one good and I heard 26 nothings.
And
Are
then
we struggling? Are we struggling with the algebra or are we struggling with the trigonometry? Okay. Where are we struggling?
I don't know if I should do which one I should pick.
Beautiful. Okay, so can I use you as a guinea pig? Beautiful. You want to do R or you want to do S? R, okay. You would think that would be a pirate's favorite letter, right? R, it's not. You know what it is? The C. Thank you. All right, so we're going to do R. And we're going to use the 15.5. Okay, so, and we know this. So let's start from scratch and label all three sides as opposite, adjacent, and hypotenuse. Which one's the hypotenuse? We'll do the easy one first. S, good. Hypotenuse. Okay, which side is opposite? No, that's the angle. Which side is opposite the angle?
R.
I'm sorry?
R.
R, correct. Do you see why that's the opposite side?
Yeah, sorry.
So therefore, this is adjacent.
Yeah.
Okay. We know the adjacent side. We're solving for the opposite side. Which trig function is that? Say again?
Tan.
What is it?
Tan.
I'm
Or
sorry?
tangent.
There you go. Are you with us?
Yeah.
Okay, so therefore set up your equation. The tangent of 15.5 is equal to the opposite side over the adjacent side.
Yeah.
Okay. Are we good on the algebra there?
Yeah.
Good, so then tell me what R is.
R is 9.7.
2 decimal places.
7.1.
7-1? Okay. Are we good? Any problems? Beautiful. Okay. I will admit that solving for S is a little trickier because we haven't done this yet. The first problem in yellow, the triangle in yellow, had the hypotenuse. This one is a little bit different. Changing colors here. The labeling of the side stays the same. R is still the opposite side. 35 is still adjacent. The hypotenuse is still S. But now I want to solve for S. And I know 35. What function involves the adjacent side and the hypotenuse? Cosine. Then it becomes a matter of plug and chug. Cosine of 15.5 is equal to 35 over S or S over 35? Beautiful. Okay. Let's talk about solving this, because there's two approaches to it. One is the traditional proper algebra way to solve it. I don't care about that at all. I'm going to show you a trick that'll save you a lot of hassles. Okay. But let's talk about the algebra just because I feel like I need to do it just because I'm a math teacher. How would I solve for S? I would multiply both sides by S. I would divide both sides by the cosine of 15.5, leaving S by itself on one side, and do all that other garbage. Okay, forget about it. We're going to do a technique called the switcheroo. The switcheroo is very simple. If the variable that you're looking for is in the denominator over here, you're going to switch the left side with the denominator. So these two things just switch. And it becomes S is equal to 35 over the cosine of 15.5. So we're going to cut out the middleman with all that algebra garbage and just use the switcheroo to get S by itself. Plug and chug, tell me what S is. Whoops. $36.32?
Yeah.
Can somebody confirm? Good. Do those answers make sense? Yeah. R is the smallest side, is opposite the smallest angle. S is 35, which is opposite the middle angle, and the hypotenuse is the longest, so we're good to go. So a lot happens in that problem. Number one, you have to be able to identify the sides that you're working with as opposite, adjacent, and hypotenuse. Number two, you need to be able to set up a trig equation. And then this one gets a little hairy because all of a sudden we get introduced to the switcheroo. Okay, whose head is ready to explode? Nobody? Good. So we're going to keep going. Any problems? You'll get better at this as you practice. You'll be able to recognize the opposite, adjacent, and hypotenuse a lot quicker after you've practiced some of these problems. I've given you a lot of little tips there that will help you along the way to make sure that you're on the right track. I would suggest you use those. Okay? We're good? All right. Now, we get into the fun part. One thing we haven't addressed is, what if I want to know the angle measures? So the first couple examples we did, and everything that we set up so far, was predicated under the idea that we knew how big the angle measures are. But now I have this triangle, 3, 4, 5 triangle, and I want to know how big the angle is. In order to do that, we're going to use something called an inverse function. Well, what does an inverse function do? That was a real question. What does an inverse function do? Yeah. So if I, what's the inverse of addition? What's the inverse of squaring? Square root, right. So think of an inverse function as the function that undoes what you're trying to do. Well, remember, sine, cosine, and tangent are functions, so there should be inverse functions. Look at your calculators. In particular, find the sine button. What do you see above the sine button? Right. Now, that's not sine to the power of -1. That's the way we write inverse functions. It makes no sense whatsoever, but that's what's happening. Those are the inverse trig functions. And if you're okay with this, and I'm assuming that you're, I mean, you may not have perfected this, but you're kind of okay with this approach, yes?
Yeah.
If you can do this, then this is real easy. It's just going to take some explanation to get you to that point. I'd like to know how big angle P is. What can you tell me about the measure of angle P?
the opposite equals 30?
Simple, dumb it down a little bit. What's the smallest value that angle P could be? No. 0. What's the biggest it could be? 90. It's got to be between 0 and 90. Okay? That seems like a stupid statement. It will become relevant in a couple other blocks. All right, so how do we do this? All we do is what we just did before, except we throw in an extra step. Okay? Now that made no sense. So I'm going to do it here because I think the next slide is a little confusing. Let's suppose I knew angle P, and I'm using the function, I'm going to choose to use sine. You can use whatever function you want. I'm just going to use sine. I'm going to set up a sine equation. Okay, so the sine of angle P, this is the stuff we did on the first slide, is equal to what? 3 over 5. Okay. Now you're asking yourself, why did he leave that big gap after the equal sign? I'll get there in a second. Any problems with this? This is what we did when we started it. That by definition, the sine of angle P is a ratio of the opposite side over the hypotenuse. I want to get P by itself. So I'm actually taking the sine of P, so I undo the sine of P by taking the inverse sine of P. That's bad math. Why is that bad math? Because I did something to one side of the equation that I didn't do to the other side, so now you see why there's a gap there. What happens when you take the inverse sine of the sine of P? What am I left with? In other words, what's the left-hand side of this equal sign become? P. And this, you get off your calculator. Go ahead, type that into your calculator. Make sure you're typing in the inverse sign, not the sine. And make sure you use your parentheses accurately. $36.87.
Yes.
Okay. Having done that, A, does that make sense? And B, how big is angle A?
Subtracted from
Beautiful. You could do another trig equation. But why? Again, keep it simple, stupid. Just subtract it from 90. Or 90 plus 36.87 plus A equals 180. Regardless of which technique you want to use, just do simple subtraction. Okay? To keep this inverse trig function simple, all you're going to do is set up a traditional trig function and then solve it by using the inverse function. Okay? Which is exactly what I did. The sine of P is 3 over 5. Take the inverse trig function and we're good to go. All right. Now, I'm not going to give you much discussion on this. I'm just going to cut you loose. But this is going to incorporate a lot of stuff that we talked about. I would highly, highly recommend that you draw a picture first. Draw your picture, label all the sides that you know, label the vertices, check with your neighbors to make sure they have it solved correctly, and then solve the triangle. Well, what does it mean to solve the triangle? There are 6 parts on a triangle. Right? 3 sides, 3 angles. When you've solved the triangle, you know all 6 parts. I've given you 3 parts. You go find the other 3. I'm going to give you some time to work on that. Go ahead. Draw a picture, set up some equations, start solving. There's a lot of different ways to solve for each of those things. I'm not going to tell you what technique to use. Don't sit there and do nothing. Get in there and try this.
do you like when you're using like the trig, like the trig form, like things? How do you like find the number that you put before the equation?
If I understand your question.
Like if I'm trying to solve like for A, like if I'm doing this, but I have to like try to put this in and then like.
No, you set up an equation first, and then you should, the last thing you should do is pick up your calculator. Get in the habit of setting up equations first.
Lowercase
How do I know it's?
So we have the adjacent draw coordinates. And then okay, so it's 13 over 18, right? Oh, yeah.
Okay, so stop what you're doing for a second. I know you're just getting started on the problem, but let's make sure that you all have the triangle set up correctly. Okay. I know I'm going to be working with a right triangle. How do I label the right triangle? C. Okay, that should be pretty obvious, yes? Now you have to decide, do you want A to be up here or do you want A to be down here? And there's no wrong answer. How many of you made this A? Raise your hand. Oh, it's about 50-50. Okay, so I'm going to put A up here just for giggles. That would make that B. Okay. Uppercase letters because they're vertices. Where is the 13? Here or here? Bottom or side? Bottom, very good, because it's opposite the angle A. Where is the 18? Side or hypotenuse? Side. And what are we going to label the hypotenuse? Lowercase c. Okay, so your triangle should look like that. If you switch your B and your A, that's fine. You're just going to have to switch those two. Okay, good. Keep working now.
So I think we're right or wrong because I decided to use tan, and then I did the opposite of A, and I did the adjacent of A.
So how did you set up the opposite of A? What's your equation? Right, but that's...
I know,
Why is that there? And why isn't there a tangent there?
I don't know.
The tangent of A is equal to the opposite side over the hypotenuse. There you go. Now solve it.
But it looks like
Well, remember, you got to do an inverse trig. How do you get rid of tangents?
oh, the negative. Okay.
Okay.
I got this.
So A and A. So
You decide you want to use A, then use A. Then you can do substitute. Okay, let's stop for a second. How can you find side C? Good. You could use Pythagorean theorem, but you could also use trig. Right? That's all I had. Keep going. Okay.
Well, does it fit small, medium, large? Looks like it.
So now going line. Now.
Yes, because that's not an angle.
What are you even saying right now?
Okay, so you've had enough time to cook on this. Let's talk about it, but before we solve the problem, let me talk about common mistakes that people make. Okay? Obviously, the first mistake is going to be if you label your triangle incorrectly. If you label your triangle incorrectly, you got a whole bunch of problems going on there because you're solving for things that aren't the value that you think they are. Number two, you can only take the sine, cosine, and tangent of an angle. So to say the tangent of 13 doesn't make any sense because that's a side length. Okay, so keep that kind of stuff in mind. I'm just going to work through it, and hopefully you're far enough along in this problem where what I'm doing makes sense. If you're completely lost, hopefully I can fill in some of the missing gaps here. One of the other things that's going to bother a lot of you is there's different ways to solve the problem, and I know you want me to tell you solve it using this technique, and that's not necessarily going to happen. You can make some choices and solve it different ways. Okay, so what I would do if I was solving this problem is first things first, I would say 18 squared plus 13 squared is equal to c squared. May I? Why, thank you, that's very kind of you. 324 plus 169 is equal to c squared. So plus 169. So c is equal to the square root of 493, which is approximately equal to 22.2. Okay, any problems there? I do not want to use that value to calculate anything. I'm just solving part of the problem by finding c. Does it make sense? Yes, because c is the hypotenuse and that's the longest side. Any problems there? That's not trig, that's just Pythagorean theorem. Okay, so now we have to make some choices. Jenna? Would you like to work with A or B? Aardvark or Badger? A as in aardvark. Beautiful. Okay. I have two sides there, 18 and 13. Is 13 the hypotenuse, the opposite, or the adjacent?
The opposite.
Excellent. Which would make the 18 the hypotenuse or the adjacent?
Adjacent.
Well done. Okay, here's the tough part. Working with angle A, what function uses opposite and adjacent? Tangent. Beautiful. So the tangent of angle A is 13 over 18 or 18 over 13?
13 over 18.
Well done. Any problems so far? And again, you'll notice that gap shows up again. Why is that gap there? Because I know where I'm going. I know what I'm going to do next. Oh, Jenna, how do I get angle A by itself? In other words, how do I make the tangent?
Inverse.
Beautiful. Make the tangent go away by taking the inverse of tangent. That's bad math. Turn it into good math. Cancels, cancels. Angle A. Plug and chug into your calculator. Somebody help me out. 35.84 degrees. Can somebody confirm?
Yes.
Excellent. Now, did you have to do that? No. Jenna chose to use angle A. Maybe you used angle B. Tangent of angle B would be 18 over 13. You'd get a different value because it's a different angle. Okay, how am I going to find angle B? Well, I'm going to work smarter, not harder. Angle B is equal to 90 minus 35.84, which would be B is equal to 54.16. Did I do that right?
Yeah.
Okay. 1, 2, 3, 4, 5, 6. I've got all 6 pieces. The last thing I'm going to do before I move on is I'm going to see if the small, medium, large theorem applies here. I already checked C. C is the longest side. That's good. Angle A is the smallest angle. Therefore, the side opposite should be the smallest side. It is, which by process of elimination, angle B and side B would be the medium. I'm good to go. Okay, so let's stop for a second, take a deep breath. Questions on that process? At some point, I can guarantee, it may have already happened, you're just going to vapor lock. And by that I mean you're not going to know what the hell to do. Go back to the basics of trig. It's just a ratio. Just set up an equation and then solve it. If you're not sure, play with the Pythagorean theorem. Okay. But don't lose your mind over this. Pick an angle, set up an equation, solve it. So we've solved equations where we're looking for side lengths. We can now solve equations where we're looking for angle measures. Okay, questions for me? Anything you need reviewed? Again, this will become more clear as you practice some of these problems. Now, we start relating this to, I'm putting this in air quotes, real world problems. And to save you some hassles here, I'm actually going to sketch this picture for you, because this adds a little wrinkle into it that you may not have considered. As we're solving these word problems, we're going to make a couple assumptions. Unless otherwise stated, we're going to assume that things are perpendicular to the ground. We're going to assume that some knucklehead built that flagpole perpendicular to the ground. We're going to assume that you don't have one leg shorter than the other and you stand straight up and down. Okay? The reason I had this example here is because it presents a different scenario in that we have this rectangle down below us. This rectangle here. How long is this? 5.5. So notice the height of the flagpole, if we call that h, is what we're looking for in the problem. But what we're really going to solve for is this distance, part of the flagpole. Let's call it x. And then add 5.5 to it. Okay. Now, we're not going to actually solve the problem, but we will set it up. What trig function would you use here? Cricket. Go.
Tan.
Perfect. We would use the tangent here. Why?
Because you have the answers to the opposite and adjacent.
Very good. So the equation I would use to solve this would be the tangent of 37.5 is equal to x over a hundo. Solve for x. My final answer then, you'd have to add 5.5 to it to take into account the fact that you're standing. Now, there will be other problems where you won't know how tall you are, and the assumption is that you're laying on the ground with your eye on the ground, which is kind of weird, but that will make some of the problems a lot easier. In a realistic situation, when and if we go outside to measure flagpoles, which we will at some point, you're not going to lay down and put your eyeball in the middle of the parking lot. You're going to stand up and measure from your height, from your eyes, and then you have to measure the distance from your eyes down to the ground. Does that make sense?
Yes.
Okay, good. And again, we're not going to solve this. You know, we'll assume that you can do the trig associated with there. I just wanted to show you what it's like to set that problem up. Okay, last example. Go ahead, solve for x. By the way, there are at least 3 ways to solve this problem. Pick one and run with it. Regardless of what method you choose, we'll all get the same answer. And some of them are smarter than others.
No, you have to do like the negative.
Even if you did, we still won't. It's okay. I'll check around to make sure everybody else got the same answer. I see that. That is the answer. Answer yet? Answer yet? Okay, I think you're good to go.
Okay. No, my thing was.
I understand what happens. Okay, any questions for Faye? No, let's give it up for Faye, huh? Now, I mentioned that there are other ways to solve the problem. Did anybody do it differently? Did anybody not use cosine? Okay, then I will talk about a couple things. Number one, there's absolutely nothing wrong with the work that Faye showed. The only thing that I would maybe do early on is I would take the inverse cosine of both sides, but this is perfectly fine. Now, how else could you solve the problem? Well, you could use Pythagorean theorem to find the missing side and then use sine. You could have found the other side using Pythagorean theorem and then used tangent. Well, why would you do that? I mean, you can. You'll get the same answer. It's just a lot more work. Work with the information that you have. Okay? And like I said early on, this comes down to setting up your trig equation and then knowing how to solve the trig equation. Okay, so recognizing what trig function to use, set up your ratio, and then solve. But what does it mean to solve? When you're solving for the angle, you're going to have to get some inverse trig going on. If you're solving for one of the sides, then you're just doing some simple algebra. Any questions? Beautiful. Okay, I think we are done. Awesome. Let me shut this bad boy down. Discard.